This is Venkatesh Prabhu. Again, I'll be discussing about how to solve reactions using flowchart method with the help of Berkeley model now. So, first open the file, go to the new flowchart documents. The window will be open. Then press the reservoir and keep it. Then another a circle with the arrow that you connect. Then extend this fully into the system. This is going to be a substrate. For example, I'll keep it as yes. Substrate concentration is going to be 100. You OK. Then this substrate is going to be entered into J1 plus fully family. Yes. Now feed the values. Before feeding the values, assume the constant by pressing globals. K is equal to 0.234. Just assume and the flowchart and this give the value as K star and capital S plus OK and check the run. We can find out the profile which is going to be the substrate from 100, it is going to be reduced to 10. So in the reaction, the substrate S is going to be reduced from 0 to 10 and the table value will also be available. Then legends, yes, the values of initial S and K will also be displayed. So the another way what we can do is if there is a two reactor which is flowing from the two reactor and it reacts, what will be the results that we let us see now. Again, press the reservoir, give another reservoir, just drag, connect these two reservoirs using a reaction, then name this as R1, this as R2, and connect these J1 with R, and this R2 also with R. Give the initial value of R as 70, press OK. The initial value for R2 as 30, then OK. Then constant K is equal to 0.567. Go to the flowchart, then double click there, J1. Now K into R2 minus R1. You OK. Then run the program. You'll be getting the results like this. Then its legend R1 is increasing, R2 is decreasing. Initial values everything. So we could also change the time, stop time as 100 and we will also run it. Or we will reduce the time to 10, run it. Then reduce the time to off, By this way, we can be able to simulate the conditions in a reactor also. The flow sheet is going to be looks like this. So reactor 1 reactant is entered here, reactor 2 reactant is entered here, and with the rate of K1. Suppose if I want the flow sheet J1, if I change this as divided by R2 and I change the condition as R2, then press OK. What will be the results? This is going to be a straight line. Or if I'm changing if I'm changing R2 product of R1, what could be the results? And run it. So you'll be getting a graph like this. Or if I'm changing these conditions as R2 alone, R1 alone, and run it. Both R2 and R1 when you are doing, it is going to be the transforms. Or we can also change this as R2 by R1. So in all the conditions, this is going to be a transform. So either a what is that? R2 is going to be an increasing trend, R1 is going to be a decreasing trend. Will be getting like this. All the table will also be available. And we do another method of doing the same thing. Go to the flow sheet, new flow sheets, press reservoir, then press another reservoir, give another reservoir, then connect these two reservoirs with the reactions. If you want to erase it, press this circle with cross and connect everything with then this R2, R3. Assign the values for R1 as 50, assign the values of R2 as 30, then assign the values of R3 as 25. Then connect this with the R. You also connect this with this R. Then connect this with this R. Then connect this with the R. So it is a chain of reactions. Connect properly. It must be from inside the reactor. Otherwise, so I have assigned all the values. Then global values, I can put it as K1 is equal to some 0.43. K2 is equal to 0.32. I'll go to the flow sheets. Here K1 by K2 we need to select both the values into R2 minus R1. Similarly, here K1 by K2 into R3. Press OK, then run it. We'll be getting R1, R2, R3. R3 is not changing. It is a constant line. It is flowing. You can see the legend. R3 is blue color. R2 is red color. Then R1 is constant. Suppose if you want to change the R1,